few, in this environment that are scaling increasingly in this field. Bless the name of the Lord. Father, we give you praise today. Thank you for the gift of life. Thank you for your loving kindness. Abba, Father, we magnify your name. We bless your name for bringing us together to learn. Ancient of days, we commit this day into your hands. Abba, Father, we pray that you open our hearts to learning, to wisdom, to knowledge, to understanding. Lord, we thank you for your son who you have put it in his heart and made it possible for him to be available today. Lord, we ask that you bless him in the name of Jesus. Grant him wisdom beyond his imagination. That in all we do today, your name and your name alone will be glorified. In Jesus' mighty name we pray. Amen. Sit down briefly. What we are doing today is we are beginning a journey and a culture, because artificial intelligence is no longer the future. Artificial intelligence is the now. There is practically no aspect of endeavor that is not heavily influenced by artificial intelligence. There are certain careers you're pursuing today. Tomorrow, artificial intelligence will obliterate it. It will wipe it out of existence. So you have that skill, you just realize that it is redundant. Nobody will be looking at you. Therefore, with God's mercy and grace and his permission, we'll be doing this every year so that we can immerse ourselves in this new way of living, so that we'll understand what you want to do in the next 2-3 years. How will artificial intelligence scale it, or how will artificial intelligence make it redundant? There are a lot of skills today that nobody is talking to them, nobody is hiring them. Today we are speaking about data analysis and data science. In the next 3 to 5 years, artificial intelligence will become a force in data analysis and data science. So what we are doing, what we are beginning today, is to create that consciousness that this is the now. You can't think it's tomorrow. This is the now, and we have an open mind that begin to learn. We are blessed to have Dr. Nnanna Orieke, who, in spite of his fight not to be pulled out, I said to him, you cannot be here and you hide. Dr. Nnanna Orieke has PhD in artificial intelligence. He's not stopping there. He's continually increasing himself. And part of increasing his doing is also exposing himself to, thought leadership in artificial intelligence. So you guys are privileged to have him here, that you can reach out to him and, bounce things off him. If it's something that is new to him, he will also immerse himself and begin to increase. So it is something we are beginning today. We will be doing it annually so that all of us together will not be left out in this journey of now, because this is what it is. There are people who are doing their project with artificial intelligence, but unfortunately for them, they are being found out. There are also people who do not know how to use all the artificial intelligence applications that are available. So we are not scratching it. A lot of those things we will do. So the way we will flow, he will make the presentation. Just be noting your questions. At the end of his presentation, we'll take all the questions. Thank you. So with resounding ovation, let's welcome Dr. Nnanna Orieke. Thank you.
Thank you very much, Elder. Good afternoon, everyone. I would like to come down so that I'm actually at the same level with each and every one of you. I know that Elder has blown my trumpet a lot, right? but just know that I'm one of you, right? Whatever value, whatever skills, whatever talent you have, um, do not try to belittle it by whosoever is speaking to you, right? You are wonderfully made, right? And you can become anything that you want to be in life. So I will want this to be as interactive as possible, right? I know you have question time, but I will always like to make it very interactive when I'm speaking. So I will kind of call you out to kind of ask questions. Please do not feel shy. I will try and make sure that the question is not very difficult. Right. Okay, so today, just like Elder mentioned, it will be an ongoing program, and Elder, I'm also committing, right, to, I know you mentioned that it has to be like yearly, but even if we have to make it more often, right, I'm also available to support the team, okay? So today I'm going to share my experience in artificial intelligence, more like take you through artificial intelligence 101. But before I start, I want to lay a foundation. Artificial intelligence seems to be like a buzzword right now, but I didn't find it. It wasn't like me going to look for a skill. And I said, oh, it makes sense to go for artificial intelligence. So I went for it. That was not how I got into artificial intelligence. I didn't plan to do AI for my PhD. It wasn't a plan. It wasn't something that was in my mind. But I had a burden in my heart, which was for the diabetic community, right? So I had very close family members who suffer diabetes, but the rare kind of diabetes, the type 1 diabetes, and they don't get a lot of support. Right? I don't know if you know much about type 1 diabetes, but during my PhD, I had it was more like a burden in my heart to say, I want to support this community. Right? And they always prick their fingers to get blood, to measure blood glucose level. So I wanted to find a way to help measure this blood glucose level without piercing the skin. So that was how the journey of finding a solution for that problem that exists in Nigeria led me to finding artificial intelligence. So when I went to my PhD, my supervisor, I told him, I want to build this massive machine that will help predict blood glucose level. And he said, okay, you're in Nigeria, so you'll most likely not find that machine. And even if you want to build it, it might take you years. So why don't you look for something that is achievable? That was how I went to using artificial intelligence to solving it. So what is the crux of this discussion? It is to make sure that you don't live here having it at the back of your mind that, oh, I want to know AI, and you're looking for where to apply AI. I want you to come from the other side, which is what worked for me to say, I have this problem to solve. Is AI going to solve it? Good. Learn the AI to solve the problem. If AI is not going to solve it, learn the skill to solve it. But there's something that will always be in our community. The problem will always be there. And if the problem is there, the opportunity will be there. Okay? So if there's anything that I want to take out of this discussion, it is this kind of mindset. Okay? So please, you can put on the slide. Go to the next slide. So this is like a rundown of the discussion. I'm going to take you through AI 101, right? And then I will also more like demonstrate to you some of the capabilities of AI at the end of my presentation. But before I go to the next slide, who here heard about AI today for the first time? Okay, very well, no one. Who here heard about AI 6 months ago for the first time? A year ago? A year ago, good. What about 5 years ago? The first time you heard about AI? Okay, I'm seeing most hands 5 years ago. 10 years ago, no one. Okay, so for us, today, it seems as if AI is a very new thing and it's come to take over our jobs, right? In my next slide, I'm going to show you the history of AI, just to level set your mind on how far this AI has come. The first person that created this name or made this name artificial intelligence, if you move on to the next slide, it was actually done in 1956. I don't know any of us here who was born in 1956. Even Elder, I'm looking at Elder here, and I doubt Elder was born before 1956. So this shows us that AI is actually older than each and every one of us here. It was named by John Carlton, right, in 1956. But the very first AI, right, the kind of AI is more like, just to level set your mind, is trying to make computers behave like human beings, reason like human beings. The very first person, I don't know if you know anyone called Alan Turing. So Alan Turing created this Turing test, right? A way of measuring intelligence in machines. In 1950, to tell you how far this has been grown, before it was called AI, in 1950. So he created this Turing test, which is a way of measuring intelligence in computer. And how is this test set up? Imagine I'm having a discussion with you, right? For you, you're talking to a human being, right? Do you believe you're talking to a human being? I'm asking you a question, like, yes, because you're seeing me and you're seeing that I'm a human being. If, for instance, I put a curtain and you can't see who is speaking to you, and you're hearing my voice, will you still believe you're talking to a human being? So it depends. That's the point she made. It depends if you sound like a human being, because you expect human beings are intelligent, so when you're asking them questions, they should respond intelligently. So he created this test to say, for you to know that a machine is intelligent, create this boundary and discuss with a system, but you don't know whether it's a human being or a machine. And you're asked, is this a human being or is it a machine? That was how he created the test. Up till now, people are still using that to measure how intelligent a solution, a machine is. It was in 1950. In 1952, we had this witrh system. It was a speech recognition system. I'm speaking right now. You all know that it is Nnanna that is speaking. And you know that whatever I'm saying, you can understand it because you understand voice. So human beings, we understand voice, audio. Witrh system in 1952 created a solution that will understand voice. You will speak a number and it will understand that it's a number in 1952. So this is just telling you that AI has always been there. But in 1952, what kind of AI did we have? It was called symbolic AI. And let me tell you what it means. Do you know how human beings, as an expert, right, how you reason and solve problems? We typically reason with symbols. So what the systems of AI of 1950s and up till 1970s were using symbolic system to do was, they will say, I know a doctor, I'm going to convert the knowledge of this doctor to symbols and rules. So I know that you can be sick. And for you to be sick, these are the symptoms you will have. And for you to have these symptoms, it means that you most likely might be suffering from bacterial infection. So what would they do? They will go and create a symbol. This is a human being. If a human being has bacterial infection, the temperature will be higher than normal. If a human being has bacterial infection, the weight will drop. They created all these rules, and they put it in a machine. And then they will bring somebody and say, help me find out if this human being has infection. And all those rules that they documented, the machine will reason over it and then bring out a response. No, this person does not have an infection, bacterial infection, because ABC, all those rules that you've documented. That was what they called expert systems. Human beings will kind of use our knowledge, convert it to rules, put it in machines, and they are then able to use our rules that we created to solve problems. In 1972, you had what you call the Mycin system. It was an expert system. It was developed in Stanford. That system was used to diagnose bacterial infection and also prescribe drugs for it in Stanford. But it wasn't put to use because of course, ethics and legal requirement. They didn't put it to use in 1972. So this symbolic reasoning is a very difficult thing to do. Because imagine I want to get the knowledge of a doctor. I have to sit him down, ask him all the things that he does, and capture it as rules, and put it in a machine. So it was not scalable. What did they have to do? They had to go down to what you call the sub-symbolic way of solving things. What is this sub-symbolic way of solving it? One of it is what you call machine learning. Right? So this kind of became another way of solving problem. You're no longer doing the symbolic way of trying to capture the rules, but you're going to the sub-symbolic way. Let me explain to you why this is super important. Do you know how, if I show you a goat today, will you identify a goat? You will. Okay. I'm sure that you started identifying goats when you were small, as a baby. Do you know how you build that image of a goat? Most likely, because somebody would have shown you that this is a goat. And then tomorrow, your dad is showing you that this is another goat. The first goat was black. The second goat was white. But you didn't get confused. You still know that this is still a goat. If I bring something that looks like a green goat today, you will most likely say that it's a goat. Because it's also in the shape of a goat, in that form. So how did you learn? Your dad or your mom did not write any equation for you to say that if this is a goat, the head must be 10 centimeters long, or the tail must be X centimeter long. It didn't write that thing for you, but you were able to get, right now you can say a goat that you've not seen before, you can identify it as a goat. So how did we achieve this in science, in computing? It was through machine learning, which is a sub-symbolic way of doing things. How do we do it? It's very simple. It's the same way that you learn. I will bring a lot of data, and I'll tell you this is a goat. I will show it to the machine. This is a goat. This is a goat. I will bring another one and show this is not a goat. I will show the machine. And it keeps learning. If it makes a mistake, I will correct it. Just like you must have made a couple of mistakes when you were growing up, and your parents said, no, that is not a goat. This one is actually a cow, right? And so you build those images in your head. The same thing is happening in machine learning by saying, I don't want to tell you specifically how this is a goat. I will show you samples, and you're going to build that. You're going to learn how to identify a goat. So in machine learning, what you do is you show a lot of data. So it means you're not depending on something, data. I'm going to show you a lot of data, and you're going to make up your mind on what is the boundary between what a goat is and what a goat is not. That is machine learning. And this solved a lot of problems. If you go to the bank today, I want to identify who I should give a loan and who I should not give a loan. What do? I bring information of people who have defaulted and the people who have not defaulted, and I will train a model to identify who will default and who will not default. If you're doing machine learning today, this is exactly what you're doing. So think about scenarios. There are many, many scenarios. I want to predict how old Elder is. I can actually give a number. It's not because Elder gave me his date of birth, but because I actually have seen a whole lot of people and can guess what their age is, and I'm able to predict. So what is the important thing in machine learning is that you're okay if you make mistakes. It's not like your typical science where you must be right. So in AI, it's okay to make mistakes. I can say that you will not pay me back my money. But you can actually pay me back my money. But it's okay. So imagine a scenario where you want to cross the road. How many of you did physics? How many of you did physics? Just a couple of you. How many of you can cross the road? Virtually everybody. But you do not know the science behind, you don't know the speed of the car coming. You don't know the speed at which you're going to run. But you're able to cross the road. Why? Because in our head, we've actually built that, through our experience, know that no matter how fast this car is coming, I'll cross the road. So you're not looking for an exact solution. You're looking for a sufficing solution. In life, what we do most of the time is we're not looking for exact solution. We're just, what will work? We'll just use it and we'll pass. That's machine learning, learning from data. But this could solve just a kind of problem, but there is a lot more that we do. You're seeing my face today, right? Tomorrow, if you see me, you will most likely identify that this is Nnanna. Because you've built a picture of me in your head. It was easy for us to do machine learning and solve problems. But in the 2012, we wanted to go beyond just showing data and predicting things. We wanted to be able to do the things that human beings do, which is see. I want to be able to see. I want to be able to speak. I want to be able to reason. And that cannot be solved by very simple mathematical algorithms that we have. For you to solve it, you need something that looks like the human brain. And so we have what you call the neural network. You know, our brain is made up of neurons. So let me tell you how you reason. Your brain is made up of billions of neurons, right? As small as your head might look, but there are lots of neurons in it. Each neuron has what you call dendrites. So if you're looking at my hand, just see it as a connection to other neurons. This is my 5 fingers, but it could be more, right? So each neuron is like an input. That's what I use to receive signal about my environment. And when I get the signal, I'm going to process it. When I process it, I will know whether I should say, I should light up a signal, or I should not. Just see that there's a bulb. Whether I should light up the bulb, I should put it off. That's how we reason. That's how you're able to learn all the things. Like your parents are telling you, this is a goat. It's lighting up some neurons in your brain because you're seeing an animal. It's getting into your brain. It's lighting up some of the neurons, and it's making an impression in your mind that this is a goat. So the next time you see that goat, it will light up those things that it lit up before and relate it to a goat. That's how we reason. But that's the simplistic way of explaining how we reason. Honestly, not to tell you that that is the true way that we reason, but it's a simplistic way of explaining it. And so scientists went to represent that same thing, called neuron. And then they now stacked it up. Our brain, I said, is made up of billions of neurons. They now stacked it up, and they formed what you call the deep neural network, which is what you call deep learning. And with that, you're able to see. So how many of us here use our phone, the camera of our phone, to unlock our phone? Your face, you actually use that, which is deep neural network. All it's doing is capture your face, the signal from your face, and then pass it through a deep neural network model to predict who you are. But there's one clear thing I want to tell you about what all these things, they existed, but you didn't know about AI, but they've been around. Why is it that now you now know about it? It's everywhere. It is because of the fourth one, right, which is called the generative AI. So let me tell you one simple difference between all these things I've explained and the new one. All the things I've explained, I said I showed you something, and I'm telling you that it is going to result to another thing. That thing that I showed you, the goat, you typically will call it independent variable in mathematics. because you're not controlling the goat. The goat is there. It's not like you created the goat. So it means it is independent. You can't control it. The name that you gave it, goat, is dependent on that shape that you saw. If tomorrow they don't tell us that we shouldn't call it goat, we should call it goatee, the animal did not change, but the name we called changed. So that thing that you call it is what you call your dependent variable. So all these three that I mentioned earlier, from 1950s to 2012 and the rest, they were all based on you predicting the dependent variable, right? I want to predict who will churn or who will not churn. What I'm doing is who will default on this loan or who will not default on this loan. I'm only predicting their actions. I'm not predicting them themselves, I'm predicting their action. What generative AI did, which is the revolution, is that it helped us create the independent variable. I hope you're following. It helped us create the independent variable. So rather than me saying, I want to know whether Nnanna is going to pay back this loan or not, I'm going to create somebody that has not been created before, that has not been born before. And I'm saying that this creature will default on a loan. So I've learned how to create the independent variable. So I've learned how to make a goat and say that this goat will run faster than every other goat in the world. So we all learned how to create that independent variable. That's the generative AI thing that you've been talking about. And that's why it is a revolution. The world has not experienced anything like this, and it's changing everything that we've ever done, right? So AI now knows how to write. You can call it your own property, because it's not anywhere in the world. You created it. It learned how to write. I trained it to know how to write. And so I can use it to write my project, right? And then somebody will come and say, no, you used AI to write it. But it is skill that you were able to create something new that nobody has ever created before, right? So that is the new thing that you're going to see in generative AI. If we go to the next slide, just kind of build it out, this is just an explanation of everything that I've said, right? Where in the classical one, that is the one I explained, up to deep learning, what we were doing is we give it our training data. If you're looking up on that first row, classical machine learning, you give it your training data, and then you give it a model, and then train it, and it's able to predict things. That's the thing that we've been doing. But get to one point, machine learning can only work with data. It can only work with numbers. Only numbers. It cannot work with any other thing. It only works with numbers. So if I want to predict who will default on a loan, I will most likely give it maybe this person's age, this person's numerical. So if I'm going to give it somebody's picture, then it will not accept it, right? But you are able to use your phone and the image. How are you doing it? But you know that whatever picture you have is made up of ones and zeros, right? Whatever picture you have is just ones and zeros. That's what you're using to build that picture. So I'm passing all those arrays on ones and zeros to it. It's not like it's seeing it the same way you're seeing it. All it's seeing is actually numbers. Do you get? Because it can only reason with numbers. So what are we now doing with this generative AI, which some of you call ChatGPT, some of you give it different names, right? What they did was they gave it a lot of data. So training is now big data. I'm training with a lot of data. They went to the internet and got a lot of the information we have on the internet, right? Got all those information and then used it to train a model. And that model was now understood how to read, understood how to write, because I actually trained it with the test on the internet. So what is this GPT model doing? I'm only giving it, when I tell it, write a poem for me, and it goes to write a whole lot of things. it's creating new articles for me based on the fact that I said, write a poem. Because it just knew by training it that if I say my name is, then the next thing that should follow should be actually a given name. That's what was used to train it. If I tell it to write a poem for me, it knows that the next thing that should follow should be something that has to do with the poem. If you give it a particular poem, it should then write based on that poem. But everything that is generating is based on probability. There is nothing that says that it is right. I was just, if I call you out now to say, tell me about Presbyterian Church of Nigeria, I am very sure that if you give me the same answer as she, I will believe that you people copied. The same thing happens to us in school. Your teacher would train you with the same notebook, with the same, on the same lecture hall. And then when you people produce the same result, the same answer, he then comes and says you copied. Why will he assume that you copied when the training material is the same? Why can't we produce the same thing? Right? So that is the same behavior that you see in generative AI, where I ask it a question, and it will generate something very, very new. Very, very different. If I ask another time, it's generating something new. It's the same way that we human beings behave. That is the way it was trained. Right? So you now know the way these two things are trained. If we go to the next slide, right, this is the type of classical machine learning, which each and every one of you can, if you want to go into machine learning, you can do any of this. If you want to predict who is taller and shorter, you do classification, right? Because you want to predict a class, who is taller or who is shorter, who will come to the church late or who will come to the church early, right? Somebody can actually do it here to say, I can take data of how people come to church, and I will predict how many people will be in this auditorium, and if we should be using the kind of generator we are using. Maybe we shouldn't be using generator because most people will not come. Right? Based on that prediction, you can then plan. Or you can also do what you call regression. I want to predict how much I will be earning in the next 10 years. I want to predict how much the price of house rent will be in Lagos in the next 10 years. You're predicting numbers, numerical numbers, you call it regression. Or the last one, clustering. I want to put similar people in the same bucket. I want to do marketing, for instance. I want to put similar people in the same bucket. Clustering. Those are classical machine learning. And people that know this are the ones who are working in banks and the rest, trying to help them be more data-driven. Should you know this? Yes, please. Very, very important. The other one, if you go to the next slide, is just a representation of the deep learning. I told you it was built using neurons. This is how it is. I have a picture of 9, and I'm sending that picture of 9 to a machine, to a neural network. What I'm doing is I'm giving it the numbers, the ones and zeros of this 9, and it's getting into this brain, this mathematical brain that we have, and it is giving me an answer, 9. That is how the neural network is, right? So just know that this is how we build neural network. If you go to the next slide, this is how your ChatGPT model is trained, okay? You get a lot of data, text, images, speech, all the data that you get from your internet. You convert it to numbers. You can only train with numbers. You convert it to numbers, it becomes your training data. You pass it to what you call your foundational model, and you train the model. So that model knows how to write. It knows how to read. And then you now say, I want to fine-tune this model. You adapt it. I've trained the model that knows how to read, and I want to adapt it to chat. That's how they created ChatGPT, because they trained a model, adapted it to chat, and then you're now using ChatGPT to be asking questions, and it's now responding to you. If you now want to use this model to find out who is going to default on a loan or not, it means you have to fine-tune it for loan. You want to use it to create music. You have to fine-tune it for music. So you have music model. You have to use it to generate images. You have to fine-tune it for images. That's how large language models are developed. If you go to the next slide, kind of build this out. Okay, no, so go back. Maybe it's not showing very well, but I will give you the revolution that came because of AI, the generative AI, which you guys mentioned that you kind of learned about AI the last 5 years. And generative AI actually came 5 years ago. That's the main time that it became very popular. If you notice our mobile phone, it took like 16 years to get up to 100 million mobile phone users. For the internet, it took about 7 years to get up to 100 million internet users. For Facebook, it took about 4.5 years to get up to 100 million. For ChatGPT, it took 2 months to get up to 100 million users. So this is actually a revolution on the way that AI is changing what we do, right? Because everybody now found the best friend. In fact, one of the models, people are kind of building relationship with these models, kind of feel like these are actually human beings, and I can interact with them, right? Because they can just be like your friend who knows about every other thing, but is giving you response. If we move to the next slide, I want to kind of give you an idea of the landscape, and I'm being very practical with this so that you understand the opportunity that exists in the market. Because of this generative AI, much of what you do, you know that you're always looking for information. Whether you're a student, right, you're always looking for information to solve a problem. Or you're working in the white-collar or blue-collar job. You're always working with information. So most of us, the knowledge workers, our productivity has so increased because of the use of AI. Because it can help you generate content, right? So many people kind of feel like it's helping them save time. If you write mails, like what I get to do most of the time, I hardly write mails on my own. Like I hardly trust the mail I write. I will draft it and give it to AI and tell it, help me rewrite it. And 95% of the time, I take everything that you wrote. I'm like, geez, this is exactly what I wanted to say, but I'm not saying it the right way, right? So it's helping you save time. It's also helping you focus on more important work, right? Because I kind of feel now, I'm not going to belabor myself by writing a whole lot of things. It's going to help me do it. So I'll focus on the more important work. Depending on the work you do, it will most likely help you enjoy the work. But there's also another part of it. Many people are reluctant to admit that AI is actually helping them. Many people are afraid to admit this. And I'm saying this because it might also be happening to you. Initially, if you write something on ChatGPT and you copy it and paste somewhere else, there's a shade that it will come with, right? Most of the time, you get to remove that shade because that kind of shows that it was generated by AI. So you don't want to lead with the fact that this was created by AI. You want to lead with, I'm the one that created this thing. And so that was what happened to Braxton Monk in the US, who used it to write a law report. And then AI cited, in the legal world, you have to cite cases. It cited cases that never existed to support the position. And the guy looked at it, and it looked very nice and interesting, and submitted it. And he got to pay $2,000 fine, right, for citing things that never existed. But they looked real, right? So most people, so you're seeing this, AI is helping us, but I don't want to admit it openly, right? I don't want it to look like my job is not important because AI can actually do it. So that's what is happening to us as human beings, as employees. If we move to the next one, which is what the employer is saying, so if you move to the next slide, you will see that employers of labor, who are the people that some of you might be working for, or you will build your own companies. You also believe that AI, right, that you will most likely hire people now who have AI skills because you feel like AI is going to give you that competitive edge. So you hire people that have more AI skills. But most of the leaders are also not willing to commit money to training those skills. The people that work for them, they're not willing to commit money to train those people. So imagine this dissonance that exists. I know that this is going to help me, but I'm not empowering my people to get the skills. You're working. I know that I'm using this to work. I'm not open enough to accept it, right, as helping me. What opportunities do you think this is going to create? If we move to the next slide, and I really want you to take the next point seriously, that professionals aren't waiting for official guidance or training. The people who are going to win this AI war are people that are going to take it upon themselves to train themselves. Those are the people. Imagine now that you're going to a university and going to learn AI. I bet you that before you come out, what you learned is obsolete because of the speed, right? So that means there is only people who are willing to self-learn. There are the people who are going to take these opportunities that will be created in AI. And if there's anyone here that feels that after this training that you become an AI expert, I say you have to rethink, because you will not be one. You will only become an AI expert is after this training, you go back and you start learning on your own how to solve your immediate problem with AI. That's the only way that you become an expert. And this is a data-driven insight I'm sharing with you, right? To know that it's a level playing ground, we can all learn. I will share with you links on where you can go and learn at the end of this presentation. If we move to the next slide, right? Okay, maybe sorry, take it back, please. Take it back. Let me ask again. What are the skills that you need to learn AI? To use AI? What do you think are the skills? I've shown you how to build AI, but what do you think are the skills you need for AI? Sorry, prompting. I think she already has an idea of what AI is. So she said prompting in the thank you. In the layman term is asking questions, right? So inquisitive mind, perfect. What other skill do you need? What? Curiosity. Did you see my other slide that I presented? No. Okay, curiosity. What other point? What other point? Sorry. Time. Of course. Perfect. Very, very important thing, time. Yes. So, but I'm actually impressed with the responses you're giving me. I'm expecting somebody to say, I need to learn how to code. I need to learn Python. I need to learn, I know you're a data scientist, right? I need to learn A, B, C, and the rest. So if you move to the next slide, which surprisingly is showing you that these are the skills that you need to use, that is required in this era of AI, it means that each and every one of us here actually inherently has these skills to succeed in AI. Each and every one of us. Analytical judgment, flexibility, right? Flexibility, this is how we used to do this over and over again. Like, I can't change it, but you need to be flexible if you need to use AI, right? And the rest. And she mentioned curiosity, right? Creative evaluation, like all the rest, like you need it. And she also mentioned prompting. Yes, AI delegation. I'm delegating things to AI to do, which is more around the prompting. These are the skills that you need. So every one of you here, you have the foundation to work with AI. You don't need to be a mathematics professional or professor in maths or statistics, because in the real sense, AI is statistics and maths. Even though we don't call it, we're using an interesting term, artificial intelligence, but in the real sense, so that we don't scare everybody away, it's maths and statistics. Right. Okay. So if you move to the next slide, I'm going to talk about the trends in AI, I'm saying this so that you also know where to focus your time and in identifying the problems that you need to solve. If we move to the next slide, which is speaking to the trends, right? Elder mentioned this, which is very true, that AI is reshaping the world we live in. Not in years, not in months, but right now. I am sure Elder did not read this, my slide, to say it, but this is exactly what is the case, right? It is changing the world right now. Right? And so there is no time for you the time to learn is actually yesterday, but it's changing the world right now. It's making the impossible possible. And I mentioned this in the way I told you LLM was created. It is creating the independent variable, which was not possible. So it looks like this is now the revolution. And it is defining enterprise capabilities. If we move to the next slide, right, this is just to give you an idea of how big this market is. Over 1 billion applications, 1 billion, will be built in the next 24 to 36 months. I believe we all know how many we are in this world, right? And how many are able to write codes. If we're going to build 1 billion applications, it means we're not writing code the way we used to write it before. Because on the average, it takes a long time to build an application. But right now, every one of you here, do you know the most popular? I know I asked this question sometime when I did the presentation, but do you know the most popular programming language today? Python. Yeah, she mentioned Python. C. Cool. Any idea here? The most popular programming language that we have? JavaScript. Those are very, very popular programming languages. But the most popular we have today is English language. That's the most popular programming language. And each and every one of us here can speak English. And each and every one of us here can create applications by speaking. You know something about programming that we didn't know. I'm a software developer as well. We didn't know, but it is a skill that everything you do is documented. All the codes you're writing, you're actually documenting your thoughts in your code. And I told you AI was trained with all the information from the internet. So you had GitHub, where everybody, they built their code and they dumped it on GitHub. And then AI was exposed to that code, and it learned how to program better than most of us can program. And so what do I need to do? I'll tell it, help me create an application that will do ABC. And it creates this for me, writing the code in the best practice way of writing code. But I might not know what to do after it has written the code. But it will write the code for me, right? So just to tell you that this number you're seeing here, 1 billion, is each and every one of us here thinking about things that we want to do, and we're saying it in English, and it's creating codes for us. So do not think you're not maybe you read architecture and the rest, and you cannot write code. Well, I can tell you, create an idea for me, or whatever idea you have in architectural design, and it does it for you. So do not limit yourself. 70% of organizations are accelerating app development, right? Bringing AI into their existing apps. So in the way that we get to interact today, let me give you, I know I should not worry about time. Okay. Let me tell you things that used to happen in the era of the internet. You know that we had, when the internet came around 1989 or thereabout, businesses had to transform, right? So I create my business today. It's one brick and mortar shop. And then I'll create another part of my business on the internet, which I called my website, right? For the bankers, they will call it internet banking. They created another version of their business because people were now on the internet. People that they need to bank with them are also on the internet. Then in the early 2000s and the 2000, we had the mobile phone that came into Nigeria. Everybody now moved to the mobile system. What did they do? The banks also needed all the commercial, they also needed to go to where people are. So what did they do? They created mobile apps. So if you're building a business now, you have your own brick and mortar, you have your internet app, you now have your mobile app, right? And you're then telling people to come through those channels to consume your business. Imagine you're creating your business today and you don't have a mobile app. You're most likely not going to scale. You can't compete, right? So it's now a competing attribute to have a presence where your consumers are going to be, which is now in the mobile part. How do you think you're going to create your business for the era of AI? How? How can I transform my business now to be AI ready? One channel that you see that people use to communicate with this AI, and I'm using AI in a generic way, but I'm specifically speaking to the large language model, the generative AI. How do you think people communicate with it now? You use your mobile phone, right? You still use your laptop and the rest. But you most likely communicate with it using a chat interface, right? So not like I'm building a mobile app. I'm having a conversational way of communicating with it. Your chatbot, your ChatGPT, your Copilot, or whatever you call it, you have a conversational way of asking a question and it gives you a response. You people kind of relate as if it's a human being next door, right? So it then means that if you want to be competitive, you then have to transform your business to become conversational, right? So it is now a skill, right, for you to then make your business conversational by making it AI ready. So that point I shared with you on what the businesses are doing, they're actually making their businesses conversational. So if you're in the bank, you have to then be moving towards conversational banking, right? And how do we like to converse? By typing and by talking. That's how we human beings enjoy. So I should be able to call my bank and speak to my bank and do things, or chat and get things done. But behind the scene, what is doing it is the large language model that is orchestrating what needs to happen. Okay? If you move to the next slide. So I'm waiting for it to come up, but I don't want to skip the point I'm making, but if you're able to share the next slide. So this is more like the point I just made, to say I'm no longer constraining the interaction by building a fixed mobile app or fixed internet banking app. I'm making it natural language oriented. So you can converse, say things the way you want to say it, and the model should be able to understand. I'm also moving away from hard coding and fixed data sets to then going to data-driven personalized experiences. So I mentioned the fact that when I'm interacting with you as a person, and I want to be sure that I'm actually interacting with a person in the Turing test, that I expect that this other person behind the scene should reason alongside me. It should be like, I'm asking it, what is your name? And it says, my name is Nnanna. I said, no, I mean your real name. I expect you to say, but I told you my name is Nnanna. Why are you saying your real name? What other real name are you expecting? And I said, no, I mean, you know that nickname I used to call you in school? That is the way human beings converse. Or if it's more like the hard-coded, what is your name? My name is Nnanna. What is your name? No, my name is Nnanna. You keep maintaining your position, right? You already will know that the person behind the scene is not a human being. It's obviously a machine, right? Because it's not interacting the same way that human beings interact. So you're seeing this data-driven personalized experience, which large language model will help you get. You're then also moving away from complex changes to like having things delivered as quickly as possible. So she mentioned time as something that is very, very important in AI, right? But the point is, time is of essence. In the era of AI, you do not wait, right? You have to, whatever idea you have to put it out, else someone else will do it, right? So people don't even wait. If you're writing any paper on AI, you no longer wait again. Like, you have to put it out there, else the time you're putting it out tomorrow, you're even seeing something better than what you have that is already out there, right? So if we move to the next slide, I'm then telling this is, if there's anything that you need to tell businesses now, right? If you're working, maybe the way you're going to show up in the office on Monday is to say, see, I have an idea of how we should go and make this business competitive. This is how we should be doing things. This is where we should be looking at. It's what you call agentic AI. The next slide will show you why I say this is important. 2025 is the year of AI agents. Note this. You've all used ChatGPT to communicate. When you ask ChatGPT a question, what does it do? It gives you a response faster than a human being can. Okay. That is very, very good. But most of the time, good responses don't come easy. Right? If I create a solution, like the ChatGPT, which is very generic, can solve, it knows everything, and I'm asking it questions, and it's giving me answers, it will most likely not make me competitive, because everybody has it. So Bank A is asking ChatGPT to do something. Bank B is doing the same thing. Retail B is doing the same thing. So what is now the difference? What are you offering that I cannot get? The year 2025 is the year of agents, and I'm going to tell you why. If we move to the next slide, right? If we move to the next slide, this is this is more like a sales deck, but it will give you an idea of the opportunities of this agentic AI. The AI agent will grow from 1 billion last year, 2024, to 47.1 billion in 2030. This part of AI. So if there's anything we're going to be thinking about, agentic AI. All those enterprise applications I told you about, I'm all saying that you have to create a presence, means your applications have to then become AI agents. So enterprise software will include AI agents, right? From less than 1% in 2024 to 33% in 2030. That means, like, all the applications, your core banking app, your whatever app you're thinking about, will become agentic. Most applications will become agentic. The day-to-day decisions that will be made autonomously through agentic AI, up from 0% last year to greater than 15% in 2030. So the world has moved. They've moved very fast, and they're moving towards agentic AI. I will explain what an agent is so that you kind of relate to it in your day-to-day living. If you move to the next slide, right, of what an AI agent is. If you have an assistant today, right, just hypothetically, I know you're young people and you don't have assistants, right? But just imagine it in your head that you have an assistant. Okay, you have an assistant that will help you study. If you tell the assistant that it should help you explain an idea your lecturer taught you, and it goes like ChatGPT to write wonderful things for you, and you read it and take it to the exam, do you think you will pass that exam or not? Just think about it. Like, do you think you will pass that exam or not? You will most likely not pass that exam, because I'm not trying to despise our lecturers in Nigeria, but most of it, they will come and say, this is not what I taught you. I gave you this book, and you're writing. So my dad was a lecturer, right? And these are some of the complaints that when, as a kid to a lecturer, that I heard students come to complain. No, I wrote this thing very well. I read on the internet. It gave me this equation and that thing. And you came to solve a particular problem using one equation you got from the internet to solve a problem that was set. And then you expect that this should make you pass. But the lecturer is telling you, based on this defined condition, this is what you should use to solve it. You're using something open out there. So I trained the generic model to know how to read and write with information that came from whatever period I got that information. It means that I'm using something that is stale. It is not current. So whatever conversation you're having openly with ChatGPT and the rest, like, you're most likely using things that are not current. It was based on what it was trained on. So if you're then using it as your tutor in school, or using it to write your project, you'll most likely be given things that are old. And so your lecturer will say, this was written by AI, and it's not relevant to what we are doing. And so I'm going to give you 0, because you actually do not know how to use AI. Yes, he's able to write something intelligent, but it doesn't mean that something that looks intelligent is correct, right? Like me asking you what your best color is, of course, you can tell me some blue, yellow, and green, but that doesn't mean that it's correct, right? So I'm just trying to let you know that, yes, this is a model that is predicting. We don't talk about it. It's just predicting the next word to come. But nothing says that that word that was predicted is correct, okay? So when you use the generic AI models to answer questions, it will not replace your business. Your business will work the way it is. It's not going to do anything for your business. So if I have an AI agent that is going to help me learn, right? Or let me not say AI agent, if I have a human agent that is going to help me learn, what I will first do is to give that agent the book that I want you to use from the lecturer, right? To say, this is the book that the lecturer gave us. I want you to study this book and then teach me, right? So you're personalizing it. That person knows how to read. You're obviously calling the person because you know that this person knows how to read. You're not questioning whether he knows how to read, all right? You are only using the person's skill and giving him a context, which is the thing that you want him to do, to say, read this book and answer the question. So you need to bring your own data, something that appeals to you. And in our industry right now, what is it that is only you that will only have? It's your own data. I'm not going to have yours. You have your own. So what will make you competitive is that you have your data ready for AI to reason over it, right? So the amount of data you're able to give it is what will make it competitive. The other part is, I give this person this book, go read. And I'm telling this person, explain this context to me. So imagine I gave you this book to read, and I say, explain this concept to me. And then you looked at the book, and then you dropped it. And you started telling me, this concept is A, B, C, D, E, F. I will obviously know that whatever you're responding, you didn't think through it. You didn't read this one to think through it, to respond. If you send somebody to the market to say, go and buy something, as human beings, if your mom was to send you to the market and give you 1,000 naira to buy a list of goods, what do you do? Like, you what? You will go and buy it, of course. I know you will go and buy it. But why going to buy it? How do you plan how you're going to buy it? Okay, you write a list. Okay, you write a list. And then you dash out of the house. Maybe it was actually 6 a.m. that your mom asked you to go buy the stuff. Do you write the list and then you leave the house 6 a.m. to go and do for the stuff? Okay, you plan on when you're supposed to leave. Okay. And in planning on when you're supposed to leave, you have to think about when is it that the market is going to open, because you're not going to go to a market and wait to buy. In the real sense, you're actually reasoning and planning how you're going to do things, even though physically you don't think that you're doing a whole lot. But in your mind, you're planning how you're going to solve the problem, and then you're following that plan. So if I ask ChatGPT a question and it's giving me things out, do you think it's thinking of planning it? No, it's just churning out things. So for an agent, I don't need you to churn out things. I need you to think about it, because as a human being, I will think about something before I solve it. So there will always be reasoning in the agent. Very, very important skill. The agent has to reason, right? You cannot just go do something. You have to reason over the job. So if you're using ChatGPT now, there are reasoning models that are now there, that if you're asking them questions, you say, okay, wait, I'm reasoning. I'm thinking about it. I'm planning how I'll solve it. I'm correcting myself as I'm making, because I almost likely make mistakes as I'm solving it. I'm making mistakes and correcting myself. So the models now, we now have models that are able to reason. So your agent should be able to reason. And reason with your own data. So you're going to focus on the data that is applicable to that scenario, right? But let me go back to the ChatGPT one again, because it can be a very simple one to read it. When you're asking ChatGPT the question to write a mail for you, does it write this mail and send the mail for you? It writes the mail, and then you copy it and go and put somewhere and you send. So it doesn't interface with the actual world. It's a virtual agent that you're communicating with, a virtual model you're communicating with. But agents actually act. So I'll tell you, send the mail, and then it's able to craft this mail and send it on my behalf. I say, buy something. It's able to get the list and then go and buy it from the internet, and then I get it across. So it's able to actually work, do something, help me transfer money. It's actually able to complete that transfer for you. That is the difference between using the normal Copilot or ChatGPT you're working with using an agent. Behind the scene, what is controlling it is the same large language model. Whereas one is using the generic knowledge, the other one is using knowledge I apply to you. Whereas one is very quick at giving you responses, the other one is reasoning over what it needs to do to solve it. Whereas one is just giving you responses, the other one is acting, right? So this is now the year of agents. If we move to the next slide, which is kind of explaining to you the different types of agents, I now have the retrieval agent, which is the normal ChatGPT that you use or Copilot that you use. If I ask it the question, I don't expect it to just give me answers. I expect it to reason over the answer. So now I want to create an agent for LPC Yaba to help me answer questions about LPC Yaba. And I want it to be a generic agent. Then it means I want it to answer questions about LPC Yaba. I have to give it information about LPC Yaba so that it's giving me the right answer. If I ask it a generic question about LPC Yaba, it will most likely give me an answer. But it doesn't mean that it is correct. Okay? That's the retrieval agent, so it's thinking over the thing. I also have a task agent, which is, I want you to send a mail for me. It's actually sending a mail. Or I want you to go buy something for me. It's actually going to buy it on your behalf. But it is task specific. I'm not telling it, I want you to go buy something for me, and I want you to drive my car, and I want you to cook my food. Like, it is always task specific, because I'm going to give you a particular thing to do. Then the other one is what you call your autonomous agent, which is just like another staff that you have that should make decisions on his own, right? And do things on his own. So just imagine a scenario that I have an autonomous HR agent. It means that when a new staff comes in, you should be able to welcome that staff and ask that staff about all the processes that needs to happen, and say, okay, you will need a laptop, right? You need an email address. You need an orientation. It's going to call other agents. I need you to procure a laptop for this person. I need you to create a training plan for this person. These are all can be like an autonomous agent that can execute things, take decisions on your behalf. Going to the next slide is just like what you used to have yesterday. You used to have your normal RPA, and then you have a chatbot right now. But I won't spend time on this one. So this is the HRO agent I'm talking about. That a user will come in, an HRO agent will communicate with an IT agent, will communicate with a training agent to execute the work. This is how people are moving away from a single agent to having agents that are going to be working as a team called your autonomous agent. That's where the business is going to right now. Moving away from just having RPAs, going to a chat-based agent. And these are more like the tools you're going to use to create an agent. I've explained all this before, but let me highlight it again. An agent must have memory, which means it must know about you. It must have a context of who you are. It must have the data about you, the data that you need it to use. It must also be able to reason. I'm calling it here planning. It should plan. It should criticize itself. It should collaborate with other people if it needs to do so. It should also be able to act, right? It's not just there to give you responses. It should be able to act. So if you're thinking about, like, when I consult for banks these days, it's more around, okay, how do we transform this, your existing bank, to an agentic bank? What are the processes you do today that will convert to agents? So we're kind of changing your business model because this is the year of agents. And I'm telling you, going forward, this is how AI will be. Oh, what? Thank you. So by going forward, this is how AI will be. So you can go to the next one. So I believe with the points I've made so far, you already have at the back of your mind some of the applications for AI. Is there anyone that can reason, can say anyone out of your mind? Applications of AI that you, based on the discussion we have so far. Anyone? Sorry. Applications, creating applications. No, I'm asking what are the applications? What are the key applications you can think about? I will show the next level. Sorry. Budget, creating a budget. Cool. You can create a budget, which is fine. I also want you to relate it to something that you are currently doing now, right? So that you can relate to, you can already think about how you should be going forward after this course, after this class, or what you should do relating to the things that you're doing. Because what I'm going to show you next, it's going to be generic. I don't expect it to be what you're going to be doing, right? But I'm looking at what will you do tomorrow. So let's go back to it right now. So which one? Okay, you're already going to the next slide. But if you go back, I don't want to show this. Tell me what you think in your mind is the next application of AI for you. Task system. Okay. A way of doing things, yes. So he's mentioned one way of doing it, like he has a typical way of doing things. He now wants to use AI to automate some of those processes, which is fine. Yes. Creating reports. Oh, cool. Very well. So she's talking about retrieval. I want to use agent to go retrieve the right information, right? Sort of making like a manual process. Use agent to retrieve it. So in the work that you do, you can actually propose it. You can actually use agent to retrieve the, rather than do everything manual. Or you let them do manual, then you come out and say, this is your own version, and then correct that. It will make you shine. Tell me another one. Proposal. This is actually super important. You're building, like you can also think about, like you're trying to create a business. It is not the same way that you just say, okay, I think granite will sell here, so let me go and buy granite. And then you sell granite for 2 months. I say, no, granite is not selling. I think it's going to be pure water. And you go and throw it away, buy pure water. Most people do a lot of research, right, for any business that you do. And I told you AI was trained with a lot of data. So can you use AI to do this research for you and then draft your proposal that you're going to then take to some of the investors to say, well, this idea is super cool, right? I'm going to apply this idea to solve this problem. But who did the whole hard work? You came up with the idea. It's not like you're guiding it. So it's not like you're telling, just go do anything, but you're guiding it. I want you to, this is my area. I want to create a business for this area. And then you're guiding it to create the proposal for you, which is super cool. So you're giving me very, very important things. Yes. Cool. Perfect, perfect. So she also made a very, very important point, which is I'm actually using AI to appraise myself. I'm also using AI to summarize or rewrite some of my whatever document that you have. So you want to create PowerPoint. I want to present to you, and I drafted some of those slides you saw there. I actually asked AI to help me create them, right? So that it looks fine. Because I'm not a graphic designer, so I'm like, help me create something good, right? Or maybe I'm coming to you, or maybe you have this note and you want to test whether you really understand what is in it, and then AI is then asking you a question, and then I am appraising you. So just like an examiner for you. Yes. Sorry. Debugging codes. Are you a software developer? Okay. This part you mentioned, debugging code, is something that can actually keep you on the table over the night, and then you come back the next morning, and you actually will find out that, well, it's actually this small line that caused this problem. But you spend an entire day, months, and weeks trying to debug a code. Like, you can be seeing the answer in front of you, but you can't see it because you're so drained. If you're a software developer, right, you can actually be on your PC for 24 hours and you won't know that time had gone, right? And you're on the same task, trying to do the same thing. So super, super important point, debugging codes. You've all raised very, very interesting points of how you can make AI work for you, right? So aside building AI from the scratch, you're going to help AI work for you. So the next slide, which I'm going to show of how you can apply AI, if you bring up that slide, is actually speaking to the points that you raised, right? Which is, how can you improve your productivity? Because every point that you're making is more about how can you create a better self by improving your productivity. That is one key area of how you are going to apply AI. The next one that he mentioned, the task that you want to automate. How can I automate the things that are perfunctory, the things I keep doing day in, day out? How can I automate them using AI? So kindly build out the whole thing, please. The whole slide. There's just a whole lot of content in it, right? So these are all the experiences. How can you improve your customer experience? So for people who are currently doing businesses, right, you're interacting with customers, how can I use AI to improve the experience, the customer experience? And personalizing the experience for this customer, right? Or even creating content, which you also mentioned right now, about proposal that you want to create. So you kind of find out that application of AI are really things that we can imagine on our own. It's not like rocket science. They're things we can imagine. And these are really how you're going to improve the work that you have in the industry. Move to the next slide. I'm about rounding up, right? I won't spend slide in the next slide, but just I will share this slide so that you can use it for work. But I'm not going to drain this slide. But these are different applications for AI in healthcare, in manufacturing, in retail, in fintech, whichever area. So this is just to show you that AI will apply wherever you are. Right? There is no business vertical or horizontal that AI will not address. Move to the next slide. This one is also super, super important, which is what are the AI principles. Remember that this is a massive tool. How should we go develop AI? For those who are in in this class, who will be creating your own AI solution, I want you to always think about this point. So when you're building your AI model or you're doing machine learning, anything about AI, remember all the 4 phases of AI that we discussed. There is a part that you should be very, very careful of. Fairness. So this principle is actually coming from Microsoft, but a whole lot of companies are adopting it. The principle of fairness. Can you imagine, let me say for instance, this is more like my pet project or something I'm really thinking about doing, right? But I also want you to relate to it where it comes to fairness. My kids these days cannot speak my mother's tongue very well. But I cannot remember teaching my kids how to speak English. Right? I can't remember doing that. But we interact in English a whole lot. But I know they spent a lot of time watching cartoons and learning things. We're getting to the scenario where a whole lot of the models that you are using were actually trained with data from the internet. And how much of your language is represented on the internet? Very, very little. So you're already seeing a form of unfairness in the models that we are building, which will most likely perpetuate if we don't do anything about it, right? Because the ChatGPT that I'm talking to is giving me responses based on the information it was trained on, and most likely that information did not contain a lot of things from Nigeria. So I'm already actually indirectly reasoning like the people that wrote that information, rather than being my true self of what a Nigerian, the way we communicate is. Or maybe I'm creating a machine learning model. I use data that contains a whole lot of banking information. And in that banking information, most of the bankers are male. They're very few female. And the female that actually banked with us defaulted on the loan. But maybe because they used it for petty trading and it didn't turn over and they couldn't pay back. And then I built a machine learning model using that data. And it will come out and it's predicting who will default on loan or who will not default on loan. And at the end of the day, it's actually using gender, because in the training data, it saw that females were the ones that were defaulting, males were the ones that were not defaulting. So at the back of his mind, he's saying that once you're a female, you will default. So I'm already being unfair to the female gender. So things that can cause unfairness, if I'm building a machine learning model, I should be very careful of those to make sure that I balance out the data. Or if I don't have a balanced data, I should remove that. I shouldn't use it to train the model. So I don't create something that is unfair. Reliability and safety. If you're going to be building machine learning models or building AI models, you should think about where it is going to be applied. Let me say you're building it for the healthcare industry, and it's going to prescribe drugs for someone. Will you want to completely depend on AI, right, to prescribe this drug to you, or will you want a human being to be behind the scene to also advise? So it's always something about how safe is this. If I'm building an AI for autonomous driving, which is what we use today, how safe is this tool? That is also one of the key principles you should